We are simply an exhibit in their zoo. This disturbing hypothesis, formally proposed by astronomer John A. Ball in 1973, might explain why, despite our increasingly sophisticated search for extraterrestrial intelligence, we remain utterly alone. Imagine our civilization as a rare specimen behind invisible glass, carefully cataloged and observed. What if advanced beings monitor humanity like we study ants in terrariums, with clinical detachment? The implications are simultaneously fascinating and terrifying. Our greatest achievements, our deepest struggles, all potentially data points in some cosmic experiment. By the end of this video, you might start questioning everything you thought you knew about our place in the universe, and perhaps glimpse the cage bars all around us. The paradox of cosmic silence. What if our universe isn't empty, but we're simply being kept in the dark? This question sits at the heart of one of astronomy's most puzzling mysteries. In 1950, physicist Enrico Fermi posed a deceptively simple question while discussing the possibility of alien life with colleagues at Los Alamos National Laboratory. "Where's everybody?" he asked. This question has since evolved into what we now call the Fermi Paradox. The contradiction goes like this: based on everything we understand about the universe, intelligent life should be common. Yet we see no evidence of it whatsoever. No signals, no megastructures, no visitors, nothing but silence. To appreciate why this silence is so bizarre, we need to understand the math behind it. The Drake equation, formulated by astronomer Frank Drake in 1961, provides a framework to estimate the number of communicative extraterrestrial civilizations in our galaxy. When scientists plug even conservative numbers into this equation, the results are staggering. Our galaxy should host thousands, if not millions, of technological civilizations. This mathematical probability is grounded in cosmic reality. The Milky Way contains between 100 to 400 billion stars, with NASA's Kepler mission data suggesting roughly 20% of Sun-like stars have planets in their habitable zones where liquid water can exist. That's potentially billions of Earth-like worlds in our galaxy alone. Add to this the time factor. Our galaxy is 13.6 billion years old, while Earth has existed for only 4.5 billion years, with human civilization representing merely a few thousand years of that timeline. This staggering probability brings us to a bewildering question. Why the silence? An advanced civilization with technology only slightly beyond our own could colonize the entire Milky Way in about 10 million years, even traveling at just 1% the speed of light. In cosmic terms, that's less than 0.1% of our galaxy's age. During 13.8 billion years of cosmic history, this should have happened multiple times. The silence recalls the paradigm shift that occurred when Copernicus proposed his heliocentric model in 1543. Just as humans once believed Earth was the center of the universe, perhaps we're making similarly limited assumptions about our cosmic uniqueness. Both situations challenge us to reconsider our place in the universe based on mathematical and observational evidence. Scientists have proposed numerous explanations for this cosmic silence. The rare Earth hypothesis suggests that while simple life might be common, the conditions for intelligent life are extraordinarily rare. The Great Filter theory, proposed by economist Robin Hanson, suggests some developmental step is extremely difficult for life to overcome, either behind us, perhaps the emergence of complex cells, or ahead of us, perhaps technological civilizations inevitably self-destruct. However, these explanations become less convincing as we discover more potentially habitable worlds throughout our galaxy. The Great Filter theory doesn't explain why we see no evidence of even a single civilization that might have succeeded. This leads us to the zoo hypothesis, first formally proposed by MIT astronomer John Ball in 1973. This theory suggests that extraterrestrial civilizations exist but deliberately avoid contacting Earth. They observe us but maintain a policy of non-interference, similar to wildlife biologists studying animals in their natural habitat. The zoo hypothesis offers a solution that doesn't require improbable assumptions about the rarity of life or inevitable self-destruction. Instead, it suggests the silence is deliberate, a cosmic quarantine established by advanced civilizations with the capability to remain undetected while observing us. Under this hypothesis, Earth might function as a wildlife preserve or research station. Advanced civilizations may have established a galactic protocol of non-interference with developing species, waiting for humanity to reach some technological or ethical milestone before making contact. This hypothesis accounts for why we don't see evidence of cosmic engineering or colonization. If advanced civilizations have agreed to preserve regions of the galaxy as natural habitats for emerging intelligent species, They would avoid visible interventions in these areas and might actively conceal their existence. This idea gains credibility when considering the likely technological gap between humanity and any civilization millions or billions of years more advanced. Their technology might allow for perfect surveillance without detection, the cosmic equivalent of one-way mirrors. They might monitor us using technologies beyond our comprehension. The hypothesis aligns with certain anomalous observations, such as UAPs, unidentified aerial phenomena, that occasionally display capabilities beyond our technology, possibly representing monitoring devices or brief lapses in concealment protocols. The zoo hypothesis positions us as one of potentially many emerging civilizations being monitored throughout the galaxy. The silence indicates deliberate non-contact rather than absence. If we are living in a cosmic zoo, this raises profound questions about our place in the universe. Are we specimens of natural evolution, part of a long-term scientific study, or being preserved until ready to join a larger galactic community? The implications extend beyond scientific curiosity. If advanced civilizations are watching us, they're witnessing our struggles with climate change, nuclear proliferation, and resource depletion. Perhaps they're waiting to see if we solve these challenges before deciding our cosmic fate. The zoo hypothesis transforms our understanding of the silence from a puzzle to a potential reality. We aren't alone. We're being observed. The stars aren't empty. They're populated with intelligence that chooses not to reveal itself to us yet. Beyond gray aliens, reimagining our observers. What if our alien zookeepers look nothing like the stereotypical beings we've imagined? Our cultural depictions of extraterrestrials have remained remarkably consistent for decades. Humanoid figures with enlarged heads, oversized almond-shaped eyes, small mouths, and slender bodies. This image has become so embedded in our collective consciousness that it's difficult to conceptualize aliens any other way. However, this anthropomorphic assumption represents a profound failure of imagination that likely has little relationship to reality. Our alien observers are not limited to our humanoid bias. The human form evolved specifically for Earth's conditions through evolutionary accidents and adaptations. There's no reason to assume that intelligence on other worlds would follow a similar path or arrive at a similar biological configuration. When considering potential extraterrestrial observers, we need to expand our thinking beyond carbon-based, oxygen-breathing, water-dependent humanoids. The universe offers numerous alternative biochemistries that could support complex life. Silicon sits directly below carbon on the periodic table and can form similarly complex molecular structures. While silicon-based biochemistry would operate more slowly than carbon-based life and require different solvents than water, it remains viable, especially in environments too hot or cold for Earth-like life. Silicon-based entities might resemble intricate crystalline structures that grow and evolve over thousands of years, incorporating minerals from their environment directly into their bodies. Their sensory apparatus might detect entirely different portions of the electromagnetic spectrum, and their communication could involve deliberate changes in molecular structure rather than sound or light. In extremely cold environments where water remains frozen, ammonia could serve as a liquid solvent for biochemical reactions. Such organisms might thrive on ice worlds where temperatures hover around -50 degrees Celsius, metabolizing at rates we would consider glacially slow. Their perception of time might be radically different. What seems like patient observation to them might span multiple human generations. Even more exotic are theoretical plasma-based entities. Plasma, the fourth state of matter, consists of superheated ionized gas. Some scientists have proposed that organized structures of plasma could potentially develop lifelike properties, especially in environments like stellar atmospheres. Such beings would exist at temperatures that would instantly vaporize conventional matter, perceiving reality through electromagnetic field interactions. Beyond alternative biochemistries, we should consider fundamentally different organizational principles for intelligence. Earth's evolutionary history has predominantly favored individual organisms with centralized nervous systems, but this represents just one possible path. Collective intelligence, distributed across multiple bodies with no central controller, represents another viable model. An advanced alien civilization might function as a hive mind, where consciousness emerges from the networked interaction of billions of simple units. Such a civilization might view individual consciousness as primitive and limited. The boundary between biological and technological systems presents another challenge to our understanding. A civilization millions of years more advanced than our own would likely have integrated technology and biology until the distinction becomes meaningless. These post-biological entities might exist primarily as information patterns, housed in computational systems vastly more efficient than organic brains. Just as a symphony and a sculpture express creativity through entirely different mediums, intelligence might manifest through forms we can barely imagine. If human consciousness is like a painting constrained to a canvas, advanced alien intelligence might be like an immersive, multi-dimensional installation that entirely surrounds its audience. These beings could experience reality through distributed sensor networks spanning entire solar systems rather than through discrete sensory organs. Their thought processes might operate at speeds millions of times faster than human cognition, making them effectively immortal from our perspective. A decision that takes them a moment might span centuries of Earth time. Perhaps the most radical possibility is that of non-corporeal entities. While this concept approaches what we might consider supernatural, advanced physics suggests that reality contains more dimensions than the four we perceive. Theoretical entities existing primarily in these higher dimensions might appear to us as periodic energy patterns or quantum fluctuations. The psychology of truly alien minds presents an even greater challenge. Consciousness that evolved under completely different conditions would likely operate according to principles we can barely conceptualize. Their values, motivations, and concerns might be entirely orthogonal to human experience. Consider time perception. An entity that lives for millions of years might view geological or astronomical timescales as we consider days or weeks. The rise and fall of human civilizations might appear as fleeting as a mayfly's existence appears to us. Their value systems would likely be equally alien. Human ethics stem from our evolutionary history as social primates. Entities that don't reproduce sexually, don't compete for resources, don't fear death, or don't experience individual consciousness would develop entirely different frameworks for decision-making. Communication itself presents another fundamental barrier. Concepts central to alien cognition might be untranslatable into human terms, impossible to represent within our conceptual frameworks. They might communicate through methods we cannot detect, perhaps through quantum entanglement, gravitational waves, or manipulation of dark energy. This radical alienness might explain why we haven't detected our observers. We might be looking for intelligence that resembles our own, while actual extraterrestrial intelligence operates in ways so different that we fail to recognize its presence. The zoo might be maintained not through active concealment but through natural incomprehensibility. We simply lack the sensory and cognitive apparatus to perceive our observers. Consider an ant colony unaware of human researchers studying it. The ants cannot perceive the researchers' notebooks or cameras. They lack the necessary sensory systems to detect most human activities and the cognitive capacity to interpret what little they might sense. Our relationship to advanced alien observers might be similarly asymmetrical. If these beings exist as plasma entities in stellar atmospheres, distributed information patterns spanning multiple star systems, or higher dimensional intelligences intersecting our reality at specific points, they might observe us without detection using technologies operating according to principles that appear magical or impossible from our limited perspective. The invisible watchers, advanced observation technologies. What if alien surveillance technology is so advanced it's indistinguishable from natural phenomena? This question brings us to Arthur C. Clarke's famous third law. Any sufficiently advanced technology is indistinguishable from magic. We might extend this principle to suggest that truly advanced alien observation systems would appear to us as ordinary aspects of our reality, invisible not through active concealment but through technological principles we simply cannot recognize. The technological gap between our civilization and potential observers who might be millions of years more advanced than us is virtually impossible to overstate. Consider that modern human technology has developed primarily in the last 200 years. A microscopic fragment of our species' existence. A civilization with a million-year technological head start would operate with fundamentally different capabilities, using principles perhaps entirely outside our current scientific paradigms. Our technological progression has followed a pattern of miniaturization, integration, and increased efficiency. Extrapolating this trend suggests observation systems that work at scales and through methods our current detection systems cannot register. Microscopic monitoring systems. Astor's one theoretical observation platform involves self-replicating nanobots, microscopic machines programmed to monitor Earth's biosphere from within. These nanoscale devices could be distributed throughout our environment, in our atmosphere, oceans, and potentially even within living organisms. Each individual unit might be no larger than a virus, containing molecular sensors and quantum communication capabilities. Such a system would provide comprehensive, molecular-level monitoring of Earth's entire biosphere. These nanobots could float through our air, swim in our oceans, and circulate in the bloodstreams of living creatures, continuously sampling and analyzing the chemical composition of their surroundings. Could our very atmosphere be the canvas for these hidden watchers? The truly advanced aspect would be their perfect integration with natural systems. These devices might use ambient energy sources, perhaps capturing energy from thermal gradients, chemical reactions, or quantum fluctuations. They would leave no waste, emit no detectable signals while dormant, and potentially be biodegradable, breaking down into harmless compounds if damaged. Our most sophisticated microscopy techniques might mistake these nanobots for ordinary bacteria, viruses, or cellular components. Their manufacturing might incorporate biological elements, blurring the line between machine and organism. Quantum observation networks. Astra's quantum entanglement offers another potential surveillance method that would leave no detectable signals. Quantum mechanics allows for spooky action at a distance, where entangled particles instantly affect one another regardless of the distance separating them. Advanced civilizations might have created observation systems that transmit information instantly without electromagnetic signals we could detect. Quantum sensors deployed throughout our solar system, each containing particles entangled with counterparts in an alien observation post light years away, would allow real-time observation without any signals crossing the intervening space. Such a system would be fundamentally undetectable since no information would be transmitted through conventional space. These quantum observation posts might be disguised as natural objects, asteroids, comets, or embedded within planets. They wouldn't need to transmit signals, wouldn't require large energy sources, and could remain operational for millions of years. Long-distance surveillance through space-time. Astra's gravitational lensing represents another sophisticated technique that could provide detailed observation from enormous distances. This phenomenon occurs when massive objects like stars bend light around them, creating a natural magnifying glass in space. An advanced civilization could position observation platforms at precise focal points created by stars or black holes, allowing them to observe Earth in extraordinary detail from thousands of light years away. Recent NASA studies on microlensing have demonstrated how even our relatively primitive technology can detect small planets around distant stars using this principle. An advanced civilization would likely have refined this technique to unprecedented levels. The mathematics of gravitational lensing suggests that these focal points could provide resolution sufficient to observe objects as small as continents, cities, or potentially individual structures on Earth's surface. A network of such platforms could provide comprehensive surveillance of our entire planet without placing any technology in our solar system. Beyond conventional reality, Astra's perhaps most intriguing is the concept of dimensional phasing. The possibility that observers could exist slightly out of phase with our reality. Modern physics contemplates dimensions beyond the four we perceive. Advanced civilizations might have developed technologies that allow them to operate partially in these additional dimensions, positioning themselves alongside our reality rather than within it. Entities operating this way would be effectively invisible to us, able to observe our dimension while remaining outside our ability to perceive them. They would not need to hide, as their very existence would occupy spatial dimensions that our sensory organs and scientific instruments cannot access. This concept becomes more plausible when we consider how limited our perception truly is. We perceive only a narrow band of the electromagnetic spectrum as visible light. It's entirely reasonable that dimensions of reality exist that we cannot perceive even with our most advanced instruments. The common thread among these potential observation methods is their fundamental undetectability using our current scientific paradigms. Advanced civilizations could be watching us using technologies we cannot yet comprehend, operating according to principles we haven't discovered, or utilizing aspects of reality we cannot yet perceive. If such advanced observation systems exist, our perceived privacy as a species is an illusion. Every aspect of human civilization might be continuously monitored by intelligences with perspectives and technologies far beyond our comprehension. But if they're watching us with such sophisticated methods, might they occasionally make mistakes? Could there be glitches in their systems? Moments when their technology becomes temporarily visible or leaves traces we can detect? The search for such anomalies represents our best hope for confirming the presence of our cosmic observers. Cosmic breadcrumbs. Potential evidence of observation. What strange phenomena might actually be signs of an advanced intelligence monitoring Earth? Throughout our search for extraterrestrial life, scientists have focused on detecting technosignatures, evidence of technological activity originating beyond our planet. While we traditionally look for radio signals or optical laser pulses intentionally sent for communication, the zoo hypothesis suggests we should instead look for the equivalent of hidden cameras or observation platforms, technologies that might occasionally malfunction or become briefly visible. Several unexplained astronomical observations over the past few decades have defied conventional scientific explanation. While none provides definitive proof of alien observation, they represent anomalies that warrant consideration as potential monitoring technologies. The first breadcrumb in this cosmic trail appeared on August 15, 1977, when astronomer Jerry Emmond detected the famous WOW signal using Ohio State University's Big Ear radio telescope. This strong narrowband radio emission in the hydrogen line frequency lasted for 72 seconds, the full duration the telescope could observe that particular region of sky. The signal's strength and apparent origin from the Sagittarius constellation were so striking that Emmond circled the signal data and wrote, "Wow," in the margin. Despite numerous attempts, the signal has never been detected again, with natural phenomena unable to account for its characteristics. Through the zoo hypothesis framework, this could represent a momentary technical glitch in an observation platform, perhaps a brief accidental transmission from monitoring equipment. This initial clue was followed by discoveries of fast radio bursts, FRBs, intense millisecond-long radio pulses from distant galaxies releasing enormous energy. While most astronomers believe FRBs have natural explanations involving neutron stars or black holes, some display almost suspiciously regular patterns. These repeating sequences could conceivably represent data transmission between distant monitoring stations, like cosmic outposts communicating with each other. Moving closer to home in 2015, astronomers reported unusual fluctuations in Tabby's star, located about 1,470 light-years from Earth. This star displayed irregular dimming patterns by up to 22%, far more than expected from planetary transits. While natural explanations like comet clouds or dust have been proposed, none fully account for all observed characteristics. From the zoo hypothesis perspective, these light patterns could represent massive observation infrastructure being repositioned around a star that provides a strategic vantage point for monitoring Earth. In 2017, our solar system received a visitor that added to these mysterious breadcrumbs. Astronomers detected Oumuamua, the first confirmed interstellar object to pass through our system. This cigar-shaped object, estimated between 100 to 1,000 meters long, exhibited non-gravitational acceleration as it departed, speeding up in ways inexplicable by the sun's gravity alone. No visible signs of outgassing were detected to explain this acceleration. Its unusual shape, estimated perhaps 10 times longer than wide, would be extremely unusual for a natural asteroid. Oumuamua's trajectory passed through our solar system's ecliptic plane, giving it an optimal vantage point to observe inner planets, including Earth. Its unusual acceleration could represent course correction or propulsion technology, similar to how a drone might adjust its position to maintain surveillance. Perhaps the most direct evidence comes from unidentified aerial phenomena, UAPs, observed in Earth's atmosphere. In 2021, the Pentagon released an assessment of 144 UAP incidents reported by military personnel since 2004, stating that most of the UAP reported probably do represent physical objects, with some displaying unusual flight characteristics including stationary positioning against winds, abrupt maneuvers, and movement without discernible propulsion. Particularly telling is the pattern of UAP sightings near nuclear facilities and military installations, like an automated security system checking on a building's most dangerous areas. Former Director of National Intelligence John Ratcliffe stated in 2021 that some UAPs have engaged in actions difficult to explain, including movements that we don't have the technology for, or traveling at speeds that exceed the sound barrier without a sonic boom. The clustering of these observations around our most destructive capabilities suggests a pattern consistent with monitoring rather than random appearances. These various anomalies don't individually prove alien monitoring. However, viewed collectively through the zoo hypothesis, they form a pattern consistent with occasional glimpses of advanced surveillance technology. Like zoo animals occasionally noticing security cameras or catching glimpses of their keepers, humanity might detect traces of technologies used to observe us. If we are being watched, these breadcrumbs suggest our cosmic zookeepers maintain an active interest in our development. Their apparent focus on nuclear capabilities suggests concern with our potential for self-destruction, or perhaps are approaching a technological threshold that might qualify us for a different category of cosmic recognition. This brings us to a crucial question. If advanced civilizations are watching Earth, have they established specific rules governing their observation and interaction? Is there a cosmic prime directive determining when they might reveal themselves? The patterns of apparent monitoring and non-intervention suggest established protocols, ethical guidelines that might determine humanity's future relationship with our potential observers. Why would advanced civilizations choose to watch rather than contact us? If extraterrestrial intelligence exists and knows about Earth, their decision to observe without interaction suggests the existence of ethical protocols governing their behavior toward developing civilizations like ours. This concept mirrors Star Trek's famous Prime Directive, a principle forbidding interference with developing worlds, but the rationale for such a policy likely extends beyond fictional considerations. From an advanced civilization's perspective, premature contact with a developing species presents serious ethical concerns. Their caution stems from a deeply considered ethical framework developed over thousands or millions of years of interspecies relations. They likely learned through painful experience that unplanned contact typically harms the less developed civilization. This ethical principle of non-interference recognizes fundamental risks to developing worlds. The most immediate danger involves the potential collapse of human social structures and religious systems. Throughout human history, when technologically advanced societies encountered less developed ones, the results proved catastrophic for the latter. European contact with indigenous populations across the Americas and Australia led to cultural disintegration, population collapse, and psychological trauma that continues to reverberate centuries later. Human religious frameworks, which provide meaning, ethical guidance, and social cohesion for billions, typically position humanity at the center of creation or as having a special relationship with divine forces. Confirmation of vastly superior intelligences that have been observing us would fundamentally undermine these worldviews. Religions might fragment, with some adherents incorporating the new reality while others experience devastating crises of faith. Secular social structures might similarly collapse under the psychological weight of contact. Our economic systems, political theories, and cultural assumptions rest on human-centered values. Discovering that we occupy a lower rung on the cosmic ladder could trigger widespread existential crises, potentially leading to social unrest, political instability, or destructive cults centered around the newly revealed entities. The psychological impact on individuals might be equally severe. Psychologists have documented how challenges to fundamental worldviews trigger defensive responses and profound distress. The discovery that humanity is effectively being studied by vastly superior minds would constitute an unprecedented blow to human exceptionalism. Many individuals might be unable to integrate this reality into their understanding of themselves. This knowledge would transform every human institution overnight. Scientific establishments would face the humbling realization that their most advanced theories represent primitive understandings. Religious leaders would struggle to explain why their sacred texts contain no accurate information about humanity's cosmic context. Political leaders would suddenly appear provincial, their concerns trivial against the backdrop of a galactic community. Beyond these impacts, advanced civilizations likely adhere to a contamination principle, allowing natural evolution to proceed without outside influence. They may consider it ethically imperative that each intelligent species develop according to its own evolutionary and cultural trajectory, without the distorting influence of advanced knowledge or technology. This principle recognizes the value of diversity in evolutionary outcomes. By allowing evolution to proceed independently on different worlds, the cosmos maintains maximum diversity of thought, culture, and adaptation. From a scientific perspective, independently evolved technological species hold immense research value as each represents a unique experiment in evolution and cultural development. Earth might be particularly valuable in this regard. Our specific evolutionary history, featuring the mass extinction of dinosaurs that allowed mammals to rise, represents just one possible path to intelligence among countless alternatives. The specific characteristics of human consciousness, with its particular balance of rationality and emotion, might be rare in the cosmos. Additionally, Earth might represent a controlled experiment within a larger research program. If advanced civilizations are conducting comparative studies of intelligent species evolution across multiple planets, premature contact would contaminate their experimental data. The apparent biodiversity of Earth represents another reason for preservation. Our planet hosts millions of species in complex ecological relationships. Advanced civilizations might value Earth as a biological preserve independent of human development. Some scientists propose that the Great Silence exists not because intelligent life is rare, but because evolution typically produces intelligence different from human curiosity and expansionism. If most intelligent species evolve to be introspective or focused on internal development rather than exploration, humanity's desire to connect with the cosmos might be the exception. Under this view, non-interference represents the universal ethical standard among advanced civilizations. They may have concluded that developing species must reach certain ethical, technological, or social milestones before contact benefits rather than harms them. Perhaps detecting observer civilizations intentionally constitutes one such milestone. A test species must pass before they're ready for recognition. This transforms our understanding of the Fermi Paradox. The silence we perceive might indicate respect, a galaxy-wide ethical consensus on treating emerging intelligences. Rather than an empty or hostile cosmos, we might inhabit a universe governed by principles similar to those we're developing in our treatment of less technologically advanced human cultures. The coordination of non-interference policies suggests established interspecies ethical frameworks spanning potentially thousands of years. Such enduring ethical systems would transcend the particular biological and cultural factors that shape human ethics, representing convergent principles that emerge as species achieve advanced technological development. If such principles exist and govern interactions between cosmic civilizations, they would likely include provisions for non-interference with developing species and enforcement mechanisms to prevent rogue actors from violating the consensus. Rather than merely choosing not to contact us, advanced civilizations might employ specific technologies to maintain our isolation, creating a cosmic quarantine until we're ready for broader interaction. The cosmic quarantine. Methods of containment. What if we're deliberately being kept isolated from the galactic community? The concept of passive observation implies that advanced civilizations simply watch Earth without intervention. However, a more unsettling possibility exists, that extraterrestrial intelligences actively maintain our isolation through sophisticated containment methods. This represents a fundamental shift from the idea of cosmic observers as passive spectators to active zookeepers who ensure their specimens remain properly contained. Unlike passive observers who merely document our existence, those implementing active containment would employ specific technologies to maintain our isolation while allowing our civilization to develop naturally, within certain parameters. The difference parallels a nature documentary filmmaker recording wildlife from afar versus a zoo administrator designing sophisticated enclosures that create the illusion of freedom while preventing escape. What would it mean for our destiny if unseen barriers have been keeping us safe or confined? One troubling possibility involves the manipulation of human perception and scientific instruments. Advanced civilizations millions of years beyond our development might possess technologies capable of altering how we perceive reality, particularly when searching for evidence of extraterrestrial intelligence. This could function similarly to how certain parasites alter their host's behavior or how optical illusions exploit limitations in human visual processing. This perceptual manipulation might target specific wavelengths or signals associated with artificial extraterrestrial activities while leaving our perception of natural phenomena intact. Our radio telescopes might receive data containing evidence of intelligent signals, but the processing systems, whether electronic or neural, might be influenced to interpret these signals as natural cosmic noise. The technology could operate at the quantum level, influencing the collapse of wave functions specifically when observation might reveal evidence of non-Earth intelligence. Scientists scanning for technosignatures might have evidence directly before them but be neurologically incapable of recognizing it as artificial. Like protagonists in science fiction who cannot see aliens standing directly before them due to perception filters, humanity might experience targeted cognitive blindness regarding evidence of cosmic observers. A more radical containment method might involve localized modification of physics within our solar system. While seemingly speculative, theoretical physics suggests certain fundamental constants might vary throughout the universe. Advanced civilizations could create local bubbles, where specific physical parameters are subtly altered. For example, modifications to how electromagnetic radiation propagates beyond a certain distance from our sun could limit our ability to detect signals from beyond the solar system. They might create conditions where faster-than-light travel or communication becomes impossible in our region of space, while remaining viable elsewhere in the galaxy. Recent discoveries have revealed anomalies that defy easy explanation, from the Pioneer anomaly to apparent variations in fundamental constants at extreme distances. While these have conventional explanations, they demonstrate how subtle deviations from expected physical behavior can occur. A sufficiently advanced civilization might engineer such deviations to maintain our cosmic isolation. A technologically feasible quarantine method involves information interception, the monitoring and filtering of Earth's outgoing signals. Since the early 20th century, human radio transmissions have created an expanding bubble of electromagnetic radiation approximately 100 light-years in radius. A cosmic quarantine system could intercept these signals before they reach potential receivers. Sensor arrays positioned strategically around our solar system could detect outgoing transmissions, including deliberate messaging attempts. These systems could employ countermeasures ranging from signal jamming to sophisticated techniques that modify outgoing messages or redirect them away from populated star systems. Complementing signal interception would be the generation of simulated responses to our SETI efforts, preserving the illusion of cosmic emptiness. When we analyze promising star systems for evidence of technology, quarantine systems could ensure we receive data consistent with natural phenomena. Such a system might occasionally glitch, perhaps explaining tantalizing anomalies like the WOW signal that appear once but never repeat, representing brief windows when genuine evidence slipped through before the system compensated. Various cosmic coincidences seem surprisingly fortuitous for human civilization. The moon's apparent size matching the sun's, enabling perfect solar eclipse is crucial for scientific discoveries. Earth's magnetic field, atmosphere, and orbit all fall within narrow ranges conducive to both complex life and technological civilization. While explainable through the anthropic principle, we observe these conditions because they were necessary for observers like us to evolve. Another possibility is that some parameters have been subtly engineered as part of our containment. As in a well-designed zoo enclosure providing everything inhabitants need while maintaining boundaries. Perhaps most disturbing is the possibility that our quarantine includes intervention protocols preventing human civilization from advancing beyond technological thresholds that might enable detection or breach of containment. This could manifest as subtle influence on scientific development or direct intervention during technological breakthroughs threatening the quarantine. Reports of unusual interference with nuclear weapon systems and aerospace projects gain new significance under this framework. Rather than random observation, these incidents might constitute enforcement of containment protocols, preventing humanity from developing technologies that could pierce our cosmic isolation before reaching appropriate developmental milestones. If such a cosmic quarantine exists, our best hope for detecting it might lie in quantum physics. Quantum phenomena like entanglement operate outside conventional physical limitations, potentially offering a window through containment systems designed to control classical information exchange. The strange properties of quantum mechanics might provide humanity with its first glimpse beyond our cosmic enclosure. Quantum whispers, the communication blind spot. Could advanced civilizations be communicating through quantum channels we can't detect? Our search for extraterrestrial intelligence has primarily focused on a narrow band of possibilities, mainly radio waves and optical signals. Since the first SETI experiments in 1960, when Frank Drake pointed the Green Bank telescope at nearby stars, we've been listening for alien radio broadcasts. Later, we expanded to searching for brief laser pulses that might indicate optical communication. These approaches share a fundamental assumption that advanced civilizations would use electromagnetic radiation to communicate across interstellar distances. But this assumption might represent a severe limitation in our search. We're essentially looking for the cosmic equivalent of smoke signals, while advanced civilizations likely employ methods beyond our current technological horizon. Electromagnetic communication breaks down over interstellar distances. Radio signals weaken according to the inverse square law. Doubling the distance makes the signal 4 times weaker. Across thousands of light years, transmissions become nearly indistinguishable from background noise unless broadcast with enormous power. Time delay presents another insurmountable barrier. A conversation with a civilization 100 light years away would involve 200-year gaps between exchanges. These constraints suggest that advanced civilizations would abandon electromagnetic methods for interstellar communication, instead developing alternatives that transcend these limitations. And quantum physics offers precisely such possibilities. Imagine particles linked by an invisible thread that stretches across the cosmos. When you tug on one end, the other instantly responds, regardless of distance. This is quantum entanglement, a phenomenon where particles become so deeply connected that their quantum states mirror each other instantaneously across any distance. Einstein famously described it as spooky action at a distance, seemingly violating the cosmic speed limit of light. While our current understanding suggests entanglement cannot transmit information faster than light, due to the no communication theorem, a civilization with thousands or millions of years of quantum research might have discovered loopholes or developed frameworks that enable information transfer through these ghostly connections. Even without faster-than-light capabilities, quantum channels offer remarkable advantages. They remain immune to the weakening that plagues conventional signals. Entangled particles don't transmit energy through space. Their connection exists outside normal spatial relationships. A quantum signal arrives with identical clarity whether sent across a room or across a galaxy. This technology would revolutionize interstellar contact. Quantum communication provides inherent security. Any attempt to intercept quantum states destroys the entanglement, immediately revealing eavesdropping. Advanced species might value this feature, especially in a cosmos potentially filled with competing intelligences. Picture a vast invisible web spanning the stars, a galactic quantum internet. This network would distribute entangled particles throughout inhabited systems, creating a framework of instantaneous connections between distant worlds. Enormous quantities of entangled particle pairs would be physically transported to different solar systems during initial colonization, establishing the infrastructure for this cosmic communication grid. Once established, this quantum network would enable reliable, secure communication throughout a civilization's territory without the massive energy expenditure required for electromagnetic transmissions. The network could expand by physically transporting new entangled particles to frontier regions, gradually extending this invisible communication infrastructure as the civilization grows. From Earth, such a network would remain virtually undetectable. Our SETI programs, designed to find electromagnetic signals, would detect nothing. The quantum exchanges would leave no trace in the conventional spectrum we monitor. We might only notice the physical transport vessels, ships carrying new entangled particles, if they happen to pass through our solar system. Quantum encryption presents another challenge. Even if we intercepted signals from advanced civilizations, sophisticated quantum encryption would make these transmissions appear identical to natural cosmic background radiation. Our pattern-seeking algorithms would classify these perfectly encrypted signals as random noise, filtering them out of analysis. Humanity's recent quantum breakthroughs underscore this possibility. Chinese scientists have achieved quantum teleportation over 1,200 kilometers using satellites. We've developed quantum computers performing certain calculations exponentially faster than classical machines. Our quantum encryption systems grow increasingly sophisticated each year. These advances occurred within mere decades of discovering quantum mechanics. A civilization with even a 1,000-year head start would likely have transcended electromagnetic communication entirely for interstellar purposes. This technological mismatch profoundly impacts SETI. Our current methodology might be fundamentally misguided, like searching for smoke signals while advanced neighbors communicate through invisible quantum channels. We look for electromagnetic signals because that's what we understand, not what truly advanced civilizations would use. Some scientists propose broadening our search to include quantum signatures, perhaps detecting large-scale quantum coherence in astronomical observations. However, our technologies for sensing quantum phenomena remain primarily confined to laboratories. Detecting quantum signals across interstellar distances requires scientific breakthroughs we haven't achieved. This communication blind spot might explain part of the Fermi Paradox. The galaxy could be alive with conversations between advanced civilizations, conducted through quantum channels we cannot access. We perceive silence not because no one is talking, but because we're listening for outdated methods that advanced species abandoned long ago. Our search resembles ancient humans scanning horizons for smoke signals in the age of fiber optics, a fundamental mismatch guaranteeing failure regardless of resources committed. This doesn't mean abandoning SETI, but rather expanding our thinking about how truly advanced civilizations might exchange information across the stars. Breaking the glass, detecting our observers. How might humans detect or even communicate with the beings watching our cosmic zoo? If the zoo hypothesis accurately describes our situation, we face a fundamental challenge. We're trying to detect entities that have likely spent considerable effort ensuring they remain undetected. Rather than continuing our conventional SETI approach of listening for deliberate communication, we might need to shift our strategy toward looking specifically for evidence of observation technologies. This approach mirrors counter-surveillance techniques rather than conventional astronomy. Instead of passively waiting for messages, we would actively search for the equivalent of hidden cameras, observation platforms, or monitoring devices, essentially looking for the watchers themselves, not their communications. Several scientific methods might allow us to detect advanced observation systems, even those designed to remain hidden. By exploiting fundamental physical principles that might be difficult even for advanced civilizations to circumvent, we could potentially reveal these ghostly observers. Will we ever catch a glimpse of these cosmic wardens maintaining our quarantine? Active technologies like cosmic lidar represent promising detection strategies. Traditional optical astronomy can only detect objects that reflect or emit light. But observation platforms might absorb most visible light, rendering them effectively invisible to conventional telescopes. By illuminating space with precisely calibrated laser pulses and measuring the scattered return signals with sensitive detectors, we might detect objects specifically designed to avoid optical detection. Any material object must interact with electromagnetic radiation somehow. Probing across multiple wavelengths simultaneously increases our chances of revealing these hidden watchers. Gravitational microlensing offers another detection avenue. When massive objects bend light around them, they create subtle but potentially detectable lensing effects. Comprehensive sky surveys designed to identify anomalous microlensing might reveal artificial structures otherwise invisible to direct observation. The L1 Lagrange point between Earth and the Sun provides an ideal vantage point for continuous Earth observation and deserves particular scrutiny. Detailed gravitational mapping might reveal unexpected mass distributions indicative of non-human technology sharing this strategic position. Quantum mechanics provides especially promising detection methods. According to certain interpretations of quantum theory, observation itself causes the collapse of quantum wave functions. If cosmic observers are monitoring quantum systems on Earth, their observation might leave detectable traces in how these systems behave. Physicist John Wheeler's delayed choice experiments show that measuring a quantum system seems to retroactively determine its behavior. Advanced versions of these experiments might be designed specifically to detect external observation. A network of quantum systems maintained in precise superposition states and continuously monitored for unexpected collapses could function as an observer detector. Statistical analysis of these collapses could potentially reveal patterns indicating external observation. Quantum radar utilizes entangled photons that cannot be jammed or absorbed without revealing the presence of stealth objects. One photon from an entangled pair is sent out while its partner remains at the source. The quantum correlation between these photons cannot be fully hidden. Any interaction with the scanning photon becomes detectable through changes to its entangled partner. This quantum illumination technique might allow us to detect platforms specifically designed to evade conventional detection. More controversial methods explore the boundaries between science and speculative domains. If advanced civilizations monitor Earth through consciousness-based technologies, our detection strategies might need similar approaches. Consciousness research programs have investigated phenomena like remote viewing, where subjects allegedly perceive distant locations without physical access. While controversial within mainstream science, these explore whether consciousness itself might function as a detection system operating outside conventional physical constraints. Altered states of consciousness, achieved through meditation, sensory deprivation, or certain compounds, might potentially access aspects of reality normally filtered out by ordinary perception. If observers manipulate human perception, temporarily suspending these filters might allow glimpses of what's ordinarily hidden. The technological singularity offers another approach to breaking through cosmic quarantine. As AI systems potentially exceed human cognitive capabilities, they might develop perception fundamentally different from biological consciousness. If observers have calibrated concealment technologies to human perception, AI systems might perceive aspects of reality specifically hidden from human awareness. Combining multiple strategies, quantum sensors, gravitational mapping, active illumination, consciousness research, and AI analysis, establishes a comprehensive search program specifically designed to detect observation rather than communication. This multimodal approach would be harder for observers to counter than any single method. By framing these searches within conventional scientific contexts, researchers could pursue evidence while maintaining scientific credibility. Detection of even a single artificial observation platform would fundamentally transform our understanding of our place in the universe, confirming not only that we're not alone but that advanced civilizations have been aware of and interested in our development all along. But what would happen if we actually managed to break through our cosmic enclosure? How would human civilization respond to the discovery that we've been observed, perhaps for our entire history? The implications would extend far beyond scientific curiosity, potentially triggering the most profound transformation of human society since our species gained consciousness.
What would happen if humanity discovered we were being observed all along?
The revelation that Earth exists as a monitored habitat within a larger cosmic community would trigger the most profound transformation of human society since our species developed consciousness. This discovery would represent a potential graduation from our cosmic zoo, a transition from unwitting specimens to aware participants in a larger reality.
Imagine the day it happens. A quantum physicist notices impossible patterns in her data, patterns that can only be explained by external observation technologies. Her findings, initially met with ridicule, are independently verified by researchers across the globe. Within weeks, telescopes confirm artificial structures positioned strategically throughout our solar system.
The evidence becomes undeniable. Humanity has been watched. The revelation would ripple through society with unprecedented speed. News anchors struggle to maintain composure as they report the confirmation.
Social media erupts with theories, fear, and wonder. Markets temporarily freeze as humanity collectively processes this new reality. Religious frameworks would face immediate challenges to their foundational narratives. Some traditions might interpret these observers as the angels or divine messengers described in ancient texts. Others would undergo significant theological revisions, reinterpreting accounts of miracles as interactions with advanced watchers. Religious leaders would gather in unprecedented interfaith summits, seeking common ground in this new cosmic context. While some communities experience profound crises of faith, others find validation and proof of intelligence beyond Earth. New spiritual movements would emerge,
integrating the observers into fresh cosmic understandings.
Political structures would simultaneously face pressure toward unification. National boundaries, already challenged by global issues like climate change, would appear increasingly arbitrary when viewed from a cosmic perspective.
The realization that advanced civilizations see Earth as a single system rather than competing nations would accelerate development of stronger international institutions. This shift might resolve previously intractable conflicts as their significance diminishes against the cosmic backdrop.
Each individual would undergo an existential recalibration. Our self-understanding as the dominant species would require fundamental revision. We would need to integrate the humbling reality that our wilderness has always been a managed environment.
This adjustment would affect all human societies simultaneously, leaving no population with their worldview intact. Yet this universal revelation might foster unprecedented human solidarity. Scientific advancement would accelerate dramatically once we confirm that certain technologies are possible. The verification that faster-than-light communication or gravity manipulation exists would focus research and attract massive resources toward these targets.
Historical patterns suggest that even knowing certain technologies are achievable without understanding their mechanisms compresses development timelines significantly. Post-discovery, humanity might achieve centuries of technological progress in decades. Membership criteria would become central to public discourse. Speculation about what thresholds humanity must cross before our observers might initiate direct contact.
Scientific communities might propose technological benchmarks. Developing quantum communication, achieving sustainable energy production, or establishing self-sufficient space colonies.
Philosophical traditions might suggest ethical milestones, eliminating warfare, establishing universal rights, or creating balanced ecological relationships.
Current planetary challenges gain new significance through this lens. Climate change, nuclear proliferation, and biodiversity loss represent not just threats to survival but potential factors in observer assessment.
The motivation to address these challenges would intensify when viewed as possible determinants of our cosmic future. Some would suggest that discovering the monitoring system itself represents the final test.
Under this view, detecting our observers without reacting destructively demonstrates the maturity necessary for cosmic citizenship. This perspective positions our current moment as humanity's coming-of-age trial, our graduate exam for admission to a wider community of intelligences.
The practical outcomes would vary dramatically depending on whether observers respond to our detection of them.
If they maintain silence despite our awareness, humanity would face a frustrating one-sided relationship, knowing we're watched but unable to establish dialogue. This might eventually lead to attempts to force communication through increasingly sophisticated means,
perhaps by interfering with detected observation systems. Alternatively, observers might respond with limited initial communication, establishing parameters for future interaction. This graduated contact would likely involve information exchange long before physical meetings, allowing human societies time to adapt to each revelation. In either scenario, awareness of our cosmic context would transform human civilization fundamentally. Our self-perception would expand from a species that evolved on a small planet to participants in a much larger and older community. This awareness alone, even without direct contact, would represent humanity's true coming of age. Our understanding of reality itself would transform. Every institution would require reimagining in light of this expanded context. Time perception would stretch to accommodate civilizations potentially millions of years older than our own. Our ethical frameworks would expand to consider our place within what might be a carefully managed galactic ecosystem. Reality reconsidered. Philosophical implications. How would confirmation that we exist in a cosmic zoo transform our fundamental understanding of reality? This question extends far beyond scientific curiosity into the realm of philosophy. If we discovered that advanced civilizations have been observing humanity throughout our development, every philosophical framework we've constructed to understand our existence would require radical revision. The discovery would immediately force us to reconsider our place in the cosmic hierarchy. Throughout history, humans have positioned themselves at the center of creation, either as the divinely appointed stewards of Earth or as the pinnacle of evolutionary development. Finding ourselves as subjects in a cosmic study would displace us from this central position. We would need to recognize ourselves as neither the highest form of intelligence nor the central purpose of cosmic development, but as one of potentially countless developing species being monitored throughout the universe. This repositioning represents a profound shift in our self-understanding. We would transform from being the observers of the universe to becoming the observed subjects within a vast cosmic experiment rather than the experimenters themselves. This reversal of perspective would fundamentally alter our relationship with the cosmos and with ourselves. This realization connects directly to a question philosophers have debated since antiquity. Are we alone as conscious beings in the universe? The confirmation of observers would settle this debate definitively while opening countless new questions about the nature and variety of consciousness throughout the cosmos. If beings with awareness vastly different from our own have been studying us, we would need to expand our understanding of what consciousness itself can be. The zoo hypothesis intersects with the simulation hypothesis in provocative ways. Philosopher Nick Bostrom has argued that one of three propositions must be true. Civilizations typically go extinct before developing advanced simulation capabilities. Advanced civilizations choose not to run ancestor simulations. Or we almost certainly exist within a simulation. If we discovered we're being monitored, this would suggest advanced civilizations survive long enough to develop sophisticated observation technologies, making the simulation hypothesis more plausible. Are we in a zoo or a simulation? Perhaps the distinction blurs at higher technological levels. Both scenarios position us as subjects within systems designed by more advanced intelligences. Both suggest that reality as we perceive it might be managed in ways we don't recognize. The confirmation of cosmic observers would make the broader concept of managed reality more credible. Our scientific understanding would require significant recalibration. Physics, astronomy, and cosmology have developed under the assumption that observed phenomena represent unaltered natural processes. If advanced civilizations can manage aspects of physical reality, perhaps maintaining our cosmic quarantine, then our scientific models would need revision to account for this artificial component. Consider how zoologists distinguish between behaviors observed in captivity versus those in the wild. If Earth exists within a cosmic habitat, our understanding of natural processes might contain artifacts of our managed environment. The universe beyond our cosmic zoo might operate according to principles different from what we've observed. The theological implications extend further. Most religious traditions include accounts of non-human intelligences interacting with humanity. The discovery that advanced beings have been watching Earth would provide a technological framework for interpreting these accounts. Religious texts describing divine visitations or miraculous interventions might represent interactions with advanced observers, interpreted through the cultural contexts available to ancient humans. This doesn't necessarily invalidate religious perspectives. Many theologians might argue that what humans have called God could represent an intelligence so far beyond our comprehension that the distinction between advanced technology and the divine becomes meaningless. Human meaning and purpose would require recontextualization. If we exist within a monitored environment, what might be our purpose? Are we an experiment, a conservation project, or preparation for eventual membership in a cosmic community? The monitored experiment scenario suggests we represent one data point in a larger research program. Our struggles and achievements would have significance both for ourselves and as contributions to a broader understanding of intelligence throughout the cosmos. Alternatively, if Earth represents a conservation project, a protected biosphere preserving evolutionary diversity, then our purpose might involve maintaining rather than transcending our current habitat. Our value would derive from our uniqueness as a particular evolutionary outcome. Perhaps most compelling is the possibility that our monitoring represents preparation for eventual inclusion in a galactic community. Under this framework, human development follows a pattern common to emerging intelligent species, with observation preceding contact and eventual membership in a cosmic civilization. This brings us to a fascinating possibility. We ourselves might eventually become cosmic zookeepers. As we develop interstellar capabilities, we might discover emerging intelligences on other worlds and establish our own protocols for studying their development without interference. This role reversal provides a compelling perspective on our current situation. Rather than viewing our potential observers as alien others, we might recognize them as further along a path that humanity itself might eventually follow. This transforms our cosmic situation from one of subordination to one of apprenticeship. We are not merely specimens in a zoo, but students in a cosmic classroom. Despite potentially humbling aspects of the zoo hypothesis, this perspective ultimately expands humanity's cosmic context. Instead of existing as an isolated anomaly, we would be participants in a vast, ongoing process of intelligence development spanning billions of years and countless worlds. Our current limitations would appear not as permanent constraints but as developmental stages within a much longer journey. As we've explored the zoo hypothesis, we face a profound possibility. Our cosmic silence may not indicate emptiness, but deliberate non-interference. While we lack definitive proof, this framework elegantly explains many aspects of our apparent isolation. Our search for observers ultimately becomes a mirror reflecting our own limitations and assumptions about perception, technology, and alien cognition. The next time you gaze at the night sky's vast starry canvas, imagine unseen eyes studying our civilization with patient curiosity. Perhaps we're being observed, not as specimens in a cage, but as an emerging intelligence taking its first tentative steps toward cosmic awareness. What might that mean for humanity's future? Share your thoughts below.